Hello everyone. Hello everyone. Today we will show you the connection of series connection and parallel connection in case of resistances. Here you will show you that there are three resistances. One is 20 ohm. You see here, this is 20 ohm resistance. This is also 20 ohm resistance. This is 20 ohm resistance, and this is 30 ohm resistance. This is 30 ohm resistance. See here, this is 30 ohm resistance. Here I will show you the parallel connection of resistances here, right? How to find connect the resistances in parallel connection. What have we do? It will take all these 3 points in one point. You see here, we have taken that. You see here, we have taken all these 3 points in 1 point, right? That means this point is coming here, and this point is coming here. This black point is coming here. All the 3 points meet at a point, right? Here also you see that all the 3 points meet at a point. This one, this is parallel connection. What you have done? This point comes here, this point comes here, and this point comes here, right? This is a parallel connection. That means all these points, this point meet at a point. Now this point, and this point meet at another point, this point, right? Now we have taken a battery cell of two cell of 1.5 and 1.5 volt. It is connected in series, therefore it is 1.5 plus 1.5, that is 3 volt, right? And beside that we have taken a LED also, right? Here you see that is a LED. Now first we will find what is the equivalent resistance of these 3 resistances when it is connected in parallel connection. We know that when it is parallel connection, we know that the equivalent resistance will be 1 by R. You see here, we have calculated 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by 20 plus 1 by 20 plus 1 by 30. Resistance is 60. 3 plus 3 plus 2 is 8 by 60, or R equal to 60 by 8, 7.5 ohm. Therefore, the equivalent resistance of these 3 resistance is 7.5 ohm. Now let us see whether we can use this connection and let us see whether this LED glows or not, right? First of all, what we do, and this point will be connected with these 3 points. You see, these 3 points will be connected. I am connecting this point with these 3 points. You see, 3 points connected with 1 point. This point with the terminal of the negative terminal of the battery, and this is the red is the positive terminal of the battery, right? And here we have taken a LED. Let us take and put these connections here, and let us see whether the LED is glowing or not. Let us see. Yes, you see here, the LED is glowing, right? That means what you get, that the equivalent resistance of this connection is 7.5 ohm. Even then the resistance, the LED is glowing. That means the equivalent resistance of this parallel connection is 7.5 ohm, right? Even though the less one is 20 ohm, it is 20 ohm, it is 30 ohm, but the equivalent resistance is 7.5 ohm, even less than that of 20 ohm, right? In this way you can find the parallel connection in case of resistances. Now I will show you how to find the resistances if we put the resistance in series connection, right? This is parallel connection, and in parallel connection we are getting resistance of 7.5, equivalent resistance of 7.5 ohm. Now we will see the connection in series connection. Now in series connection, what have we do? Let us take 4 resistances. Here we have taken 4 resistances. Let us take how to connect these resistances such that we get a series connection. Now I will show you how to make a series connection with these 4 resistances. What you will do? You have to put all these in a line. This one and this one, right? This one and this one. And what you will do? Connect these 2 resistors with a wire. Here we are connecting this with 2 wires, Here you see, you have to connect this with wires. Let us connect it with black wires, right? We are connecting this in series. And for that, what we do, we connect this resistance with this resistance with connecting wires. Connect it. I am connecting this wire. That means these two resistances are connected in series. Here you see, we connected in series. Again, these two resistors will be connected with another connecting wires. We are taking another connecting wires and we are connecting this resistance with this resistance. Right? How? We just connect one end point of this resistance with the end point of another resistance. Did you see? Right? And here also you have to connect with another connecting wires. This connecting wire is connected with other connecting wire. You see, we are connecting this resistance with this resistance. Right? This is series resistance. You see here, these two resistances are connected with a wire. These two resistors connected with a wire, and these two resistors connected with a wire. Right? And in the end, this is the end. Now we will take a cell or battery, right? And we will connect this black wire with this end of this series connection at this end, right? And we have taken this one, this LED at the other end, and let us join this point with another connecting wires. This is the complete setup of series connection. Here you see how you make it. This one is connected with the cell. You see here, we connected with the cell, negative terminal of the cell. This is one series. This is one resistance is connected with a wire with this resistance, and this resistance is connected to a wire with this resistance, and this resistance is connected with the wire with this resistance. That means they are in series connection. And at the end, we have taken one terminal, right? This connection, and let us see whether our LED glows or not. Let us find. Yes, it is glowing, right? You see. And find what is the equivalent resistance of these four resistances. Here I already told you that the resistances are, this is 10 ohm, this is 20 ohm, this is 20 ohm, and this is 30 ohm, right? The red one is 10 ohm. Here you see it is 10 ohm, right? And the green one is 30 ohm. You see here it is 30 ohm, and the blue one is 20 ohm, 20 ohm, and blue one is also 20 ohm, 20 ohm. Now we have connected all these resistances in series. Therefore, we know that the total resistance in case of series connection is capital R is equal to capital R1 plus R2 plus R3 plus R4. R1 is 10 ohm, therefore it is 10. R2 is, this one is 20, 20, this one is also 20, 20 plus this one is 30. In series connection, you have to add all the resistances, that is 20 plus 20, 40 plus 10, 50 plus 3, 30 is 80 ohm. The equivalent resistance of this connection is 80 ohm, right? And you see here, in the series connection you have to add all the distances, but in parallel connection you have to find by 1 by r equal 1 by r1 plus 1 by r2 plus 1 by r3 plus 1 by r4. But in the previous video we have shown you a parallel connection in 3 resistances. In this way we will find the connection between resistances, right? You can do it in short project also, in series connection and parallel connection. You see the bulb is glowing also, but very less, its power is very less because the resistance is high in this case, because the resistance is 80 ohm, that's why it is glowing less, right? You see here, it is parallel connection, resistance is very high, it is 80 ohm, that's why it is glowing very less, right? But if we put it in any other connection, this LED will glow in a better way, right? In this way you can find the project for some project, like you can do the series connection and parallel connection of resistances in this way. We have shown here the two way, the parallel connection also and also the series connection. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video. Here see it is glowing, but it is glowing very low because the resistance is very much high in case of series connection. In case of parallel connection, it is 1 by r equal 1 by r1 plus 1 by r2 plus 1 by r3, and in the case of parallel connection, the equivalent resistance is even less than the least resistance, right? Yet that means what we conclude that in case of series connection, the resistances are added, r1 plus r2 plus 1, r3 plus r4, but in case of parallel connection, it is 1 by r equal 1 by r1 plus 1 by r2 plus 1 by r3 plus 1 by r4, and the equivalent resistance is even less than the least resistances in the connection. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.